Continuing this series called as Beyond Full Stack Engineering, let's take a specific example, that is payobills, the app that I've been talking about in many of my videos as well. This is a finance sort of an application to help you manage your bills and remind you about when to pay them. Obviously, this can be deployed in a variety of ways, which are called as deployment models. My focus has been to create a self-hosted, bring and keep your own data sort of a deployment model where I manage the infrastructure, which means none of the data that I generate goes outside my internal infrastructure. And that is something I believe in, and I've talked about it on my LinkedIn and Instagram as well. But that's a different conversation altogether. In this video specifically, let's talk about the architecture of payabills. What are the technology choices that I've taken? We'll talk about the front end, the back end, and the infrastructure that is needed to deploy this app. Let's get started. To start off with, I'll give you a quick demo of the app. So the way I usually use this app is through a PWA, which is called a progressive web app. This means that it can be installed as a regular app and it'll behave like a native app, but I don't have to go through the complications of deploying this to either the App Store or the Google Play Store. And this is how it'll look on my iPhone and on my Android phone as well. To demo, I'm going to run the same app on my browser. Here you'll see a graph of the recent transactions plus the 5 most recent transactions that were made here. You can also add the transactions that you've made here. So for example, I can go ahead and paste the confirmation from the SMS that I got, or I can also fill this in manually as well. So all those options are available. And below that is a smart calculation about based on my bills. So here there are few bills, credit cards that I'm going to pay, and these bars here showcase that the bill is generated on this point, and I have the option to pay it through the next month until this point. So I can now figure out which days of the month I can go ahead and pay these bills to pay them together. So that's what this card is showing. And then also, for example, if I show you this card, it shows my recent payments. Let's take a look at the all transactions, which is probably the most powerful part of payabills, which shows me my historical data of everything that I've spent money on. I can click on any of these transactions and it'll show me details of that exact transaction. And below here, you can also see notes that I've added and tags that I can add to each transaction. The upcoming bit I'm working on in payabills is the ability to get reminders for bills. So because these are PWAs, you can get reminders on your phone, which are essentially, they look like native notifications, and they'll tell you that today you have to pay this bill. This is the amount eventually when I am able to parse the exact amount from bill statements. For now, they'll just tell you, this is the bill you received on this date. You should go ahead and pay it today. This is the repository for payabills. It's a mono repo containing all the microservices. We're going to take a look at the architecture here. If you want to contribute, feel free to fork this repo and submit a pull request. Here's the Figma link as well. I've designed a dark mode, and this is one of the things I want to get into the app as soon as possible. I really need a dark mode. So if you want to contribute, fork this repo and submit a pull request. Let's take a look at the architecture of payabills now. So essentially, as I said before, this is the PWA where the user gets into the app. That PWA is essentially being served through a server-rendered UI microservice. And the first time the app is launched, the server renders the HTML, sends it out to the front end, and they have the option to then save that app as a PWA. So if you open the app in a browser and push the 3 dots, or I think on iOS on Safari it's the share button, you'll see an option to add it to your home screen, and that's how you add the app. So that's the front end itself, written in SvelteKit. I'll talk about the front end philosophies and why I chose SvelteKit in a future video, but that is what I went with. In terms of the backend, there are multiple microservices I've created to target specific needs in the app. Eventually, they'll be exposed through a single gateway, but right now the front end hits all of them based on what it needs. So on the home screen, when you saw the bill and the bar that shows when the payment is to be made and when the statement is generated, those sorts of details are coming from the bills microservices, along with the option of adding a new bill. All of that is from the bills microservice written in .NET 8. There is the payments, which is manually entering your payment data. All of that is in the payments microservices, again written in .NET 8. In terms of files, this is something that is still sort of not finalized, but I have the option to go ahead and to each specific bill have the option to upload a PDF file. It's not fully ready, so I didn't show you this, but essentially it's a Node.js Express microservice that then takes in the file, saves it into a storage, self-hosted storage called as NoCoDB. I've covered this in a different video. It's on the Cube Home Lab series, so feel free to check that out as well. The final bit is the bill statement parser, along with the parser that parses SMS transaction texts. Those two parsers take data from either my Notion database, which has automation hooked in. So whenever I receive the SMS on my phone, it sends it to Notion. And then this parser has a cron job, which essentially takes in any new SMSs, parses them, and then saves it onto NoCoDB. That's written in Rust. So that's about the microservices themselves. In terms of how all of this is deployed and what is the dev workflow, I use GitHub as my VCS, as I showed you before, the repository. Whenever I merge something, for now I'm manually creating the Docker images by hand. There's a build system that I'm using as well. There's a single command that then creates the Docker image. Plus, I'm also pushing in the Helm chart if there's any update manually to a repo. So Argo CD listens to this Helm repo along with the config, which is in a different repo. Then what it does is it pulls in the Helm charts and the Docker images from these GitHub packages and the Helm charts repo, deploys them based on the value files and the versions that is written in each of these configs. Some bits are async. So for example, if I upload a file as a build statement, that files get saved synchronously to NoCoDB, and then the file service also triggers a RabbitMQ message, which then is picked up by the build service to now say that, hey, I just saw this new build statement, and now I'll do an OCR, and then this build parser will create the OCR text from the PDF and then again save it back to NoCoDB. So there are some bits which are async, and I'm using RabbitMQ for all of this. Even though the thing that I'm interfacing is with NoCoDB, internally it is using Postgres, so I just added it here. But I don't do any direct calls to Postgres. That's about the architecture of payabills. Let's take a look at how the deployment looks like. Right, so this is my Argo CD deployment on the Cube Home Lab cluster again. There is all these applications that are getting deployed. Few of them are PR related stuff, so ignore them. But all the services that I mentioned, right? UI, bills, payments, files, each of these are deployed as an Argo application. And then all I have to do, right now the sync is also manual. So all I have to do is whenever I push the new Helm chart or update the values file, just come here and do a sync, and then it deploys the latest version. Any secrets required are directly added as Kubernetes secrets or config maps on the cluster. So I didn't create Argo configs for them at this point, at least. Finally, I've covered this in the NoCoDB video as well, but I'll just quickly show you what the data looks like on NoCoDB. So this is my bills table. I had to blur out the rest of the details here, but here I have option to directly add things here too, but I do it from the app. Again, it's all about convenience. Again, transactions, the most important part, has all the transactions I've made, details about the exact SMS string that I got. Sorry, I have to blur out the rest of this again, but as you can see, it is getting attached to one of the bills and has details about whether the parsing passed or failed. The files that I upload, which are bill statements at this point, you can see they have tags associated with them. Also, they have their corresponding OCR results. So here I didn't run the OCR on them, but oh yeah, I did. So here, as you can see, it has the full text. Sorry, you have to blur it out again. So those are the tables I've created on NocoDB. Right now, these tables have been created manually, so I'm still figuring out how I would copy this over to a different NocoDB instance if somebody wants to use payobills NocoDB service. But that's something I'm still figuring out, so that's not finalized yet. Would be great if you have thoughts on this as well, so add those in the comments. All right, so that's all I wanted to talk about in terms of the specific example we're going to take going forward in this Beyond Full Stack Engineering series. Hopefully you have questions or thoughts about parts of this architecture. Feel free to add those in the comments below. But in the future videos, I'm going to be taking a look at more specifically the front end or each microservice by itself, and then details about the deployment and the automation of the deployment process, which I'm still working on anyway. The infra bit is going to be covered in the ongoing Cube Home Lab series, because that's the project I'm using to deploy all of this. So if you want to talk more about or have thoughts about how this should be deployed, or any other service that you think could help with getting this deployed on a self-hosted environment, add those thoughts in any of the Cube Home Lab videos, and I'll talk about them in future videos. Thanks a lot. See you in the next one.